All right, so in this video, we are going to compare linear functions to their parent function, which is y equals x. So this is the very basic linear function. This function, if we were to graph this, which we are going to graph it to compare, even though it says scratch area, I 100% suggest that you graph it. So much easier to look at the graphics and kind of compare it that way. You can compare it with the algebra. That's perfectly fine, but it's very nice to have it compared on the graph. So we're going to go ahead and graph that because we can see that this is in both. We're comparing both of these situations, A and B, to this one parent graph. So let's go ahead and graph that first, and then we'll talk about what we're comparing it to. So when I have y equals x, remember I can use y equals mx plus b when I'm doing this, so that I can very quickly graph this. So if it says y equals x, well that means that m must be 1, and it would be 1 over 1, and b must be 0 because I don't even see it there. So my y-intercept is 0, and my slope is 1 over 1, like that. So now I can go ahead and graph a line here, 1 over 1, just making sure it's going to go right over to the corner. So here's my parent graph. This is kind of the basic parent graph that we're going to compare both of these other lines to. So I'll do the first one in red. So complete the statements below about graphs of y equals negative 1/4 x and y equals x. So we already did y equals x. That's the blue line here. So we're going to graph this one in red. So same idea. I'm going to use y equals mx plus b like this. And really we're just going to answer the question. To compare the graph of y equals x, the graph of y equals negative 4x is, it's either going to be steeper, equally steep, or less steep. So we're just going to look. Is it steeper or the same steepness? Does it go up at the same rate? Does it go at a different rate? So this would be less steep. This would be more steep. And then if we had a parallel line, which I'm not very good at drawing freehand, would be the same steepness. So we just want to see, what does the line look like really quick? So if I have a y-intercept of 0 again, because I don't see that plus b, but now I have a slope of negative 1/4. So now I'm going to go down 1, and I'm going to go 1, 2, 3, 4, like that. And I can do the same thing here. I can go up 1 and left 1, 2, 3, 4, just so that I can have a nice straight line on my program. You only need 2 points on Alex to do this. So let's see. And I'm going to go backwards just so I can kind of see it both all the way to the edge here. Whoops. I ended up scooching it. There we go. Something like that. All right, so now we can see the two lines, and they're crossing each other for sure. So with this one, I just want to know, this is a positive slope going up. This is a negative slope. It's going down. So since we're going from positive to negative, this would definitely be less steep. And we can even think about this. 1 compared to negative 1/4. Well, 1 is bigger than negative 1/4. It would be bigger than just 1/4. The fact that we're going from positive to negative immediately means that this one's bigger. Okay, so there's a couple different ways to look at that. I can just say, well, I had a positive, now I have a negative, or I had a whole number, now I have a fraction. Either one would let me know that the fraction is going to be smaller or the negative is going to be smaller. So that's our first part. The second part is we're still comparing the graphs, and we want to know where they intersect at the y-axis. So at a higher point, at the same point, or a lower point. So they both intersect the y-axis right there at 0, because neither one had a y-intercept, right? It was plus 0 or plus nothing. There wasn't anything after the x. So we would say at the same point. All right, so we're going to look at the second statement here. So we're still comparing it to y equals x, so still that blue line. And now we're going to look at y equals x minus 2. So now if I'm thinking of y equals mx plus b, I do have a plus b. It's that negative 2. So now I'm going to go down to negative 2. That's my y-intercept. And then my slope is 1 over 1 because I don't see anything in front of that x. So I'm going to go up 1 over 1. And then I would do that same thing all the way across, up 1 over 1, 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 and go down. So there we go. There's the line. So now we're going to compare is it steeper, equally steep, or less steep? Well, because steepness has to do with the slope, has to do with how fast we're rising and running, we just want to compare, do they have the same slope here? And they do. They both go up one, right one, up one, right one, up one, right one. So they're rising at the same exact rate. So they're equally steep on this one. Because 1 over 1, 1 over 1, well, they're equal to each other, right? If I compare those slopes looking at the numbers. And the second question has to do with where do they intersect the y-axis. So we want to know, does this graph intersect at a higher point, the same point, or a lower point? Well, since it intersects at -2 right here, and the parent graph intersected at 0, -2 is going to be a lower point than the 0. So this graph is intersecting at a lower point. All right, so that's how we compare some linear functions to their parent functions. I hope that helped, and I'll see you in the next video.